I can't tell you how weirdly awesome it is to get to speak after David Malin, because I've been like in love with his photography my entire life, and it's just kind of creepy and awesome, and he escaped before I could say thank you for being awesome. So today I'm here to talk to you about why we need you to go online instead of going outside, because we need you to go online and help us study our universe. We haven't been off the planet exploring for very long. It was only about 52 years ago that the Mariner 2 mission first visited Venus, and for the very first time sent us back information that was something that we didn't learn via reflected starlight. Up until then, everything we knew about the worlds in our solar system and the things beyond our solar system came from either seeing starlight directly or seeing nebula and planets and everything else reflecting starlight. Well, with the Mariner 2 mission, we were able to actually go out and measure the temperature of Venus. And up until that point, people thought, Venus, it's in the habitable zone. This is a cloudy world. Maybe it's a tropical paradise. And when we got that data back, we found out that Venus is a kind of deadly place with a temperature that's 900 degrees. And at that temperature, you're not exactly a tropical paradise. You're kind of a place to die. And in fact, we've killed several spacecraft there. But what Mariner 2 did was it opened up a new era of space exploration. And since then, we've systematically sent spacecraft after spacecraft out all across our solar system, going from Mercury to Venus. We've visited the moon over and over again. We have gone to comets. We're getting ready to land on a new one that looks like a rubber duck. We've gone to Mars. We have visited asteroids. We've had spacecraft orbiting Jupiter, and we're sending more spacecraft out to Jupiter. We've visited Saturn over and over. The Cassini mission is still there watching the seasons change. Things are a little shoddy in the outer solar system. We've only visited Uranus and Neptune once each. And currently we're missing two things called planets. Pluto was once called a planet, and it gets visited next year by the New Horizons mission. But the one you may not know about is the asteroid Ceres. When it was first discovered, it's the largest of the asteroids. And we originally thought it was a planet too. And next summer, the Dawn mission gets to that. And so next summer, we will have visited everything that was ever called a planet in our solar system. Now, the problem is that across these decades, our ability to study our solar system has radically changed. How many of you guys use Twitter? A few of you. So it's this way of communicating that limits you to 140 characters. And each character is a byte. Well, Mariner 2 had enough tape space, it didn't even have a hard drive, it had enough magnetic tape to store 600 bytes of information, which someone who's good with Twitter will surpass during this talk. And that's all the information we got every time we downloaded information from this spacecraft. And when you're getting your information 600 bytes at a time, well, a scientist can handle 600 bytes. You sit there, you analyze it, you reanalyze it, you find every piece of information you can make a publication out of. And over time, we got better instruments, we got better hard drives, and it got to the point that 3 or 4 scientists would get together and do everything that could be done with the data. And 6 months after the data's been downloaded from the spacecraft, there's nothing left to learn. Things are a little bit different today. There is a spacecraft called Solar Dynamic Orbiter. It lives in a special gravitational point midway between here and the sun. It's not actually midway, it's partway between here and the sun. And it sends back 1.4 terabytes of information every day. That's more than my computer can handle. My little MacBook Air looks at that much data and goes, no. And unfortunately, scientists have to look at this much data and figure out how all the expletives can we handle this data and learn what the sun has to teach us. And they have to write software that throws out information. And they have to pick and choose. And science is lost because we don't have enough time to deal with all the megabytes and gigabytes and that 1.4 terabytes every single day. And so this changes how we have to deal with science. We have this new problem of trying to deal with a flood of information, and it's not just Solar Dynamic Orbiter. It's all the spacecraft out there. It's HiRISE and Messenger and Dawn and New Horizons and Cassini and all of them. And so this is where, as we try and understand all the things that our solar system has to offer and that our universe beyond our solar system has to offer, as we try and understand, we need help. And so we're trying to change how you see what science is. And most people, when they think about science, they think about someone like this. Crazy white dude in a lab coat, in a lab with things that are boiling and bubbling and electronics and probably socially dysfunctional. That's not what science always is. I'm a scientist and I do not look like that. And my office, I have no glassware in my office because I would break it. Scientists can be anyone in this room. And I actually need all of you in this room to help me do science if we're going to succeed. What I'm talking about is a new paradigm called citizen science, or at least the phrase citizen science is kind of new. The idea is kind of simple. People like me, we have scientific problems, and we can't solve them on our own. And we don't have enough students, we don't have enough colleagues, and so we go to you, and we say public. Instead of playing 2 dots, instead of playing Candy Crush, can you spend your time doing some science? And together we can solve problems. Now, it's really not a new idea to do citizen science, and we're actually not sure how long citizen science has been around. We know that architects build buildings aligned with the stars that can be used to do astronomy work. We know that there has been artwork that aligned with the features through all of history. We find observatories in the ruins of every major culture. But the idea of systematically getting people together to do science actually comes from the American Revolution. And that's a much more enthusiastic thing when I'm talking to an American audience. And this is actually the first time I've brought this up with a foreign audience. And I apologize, it's my country that started it. So back during the American Revolution, we realized weather was a big deal. And Thomas Jefferson started thinking, well, maybe weather can be treated like a science. And if we get all of the farmers to sit down and write down sky conditions, barometric pressure, what the color of the sunset is, and write down all this information day after day, we'll start to see trends and we'll start to be able to predict what's coming ahead of time. And the network of people spread out across America studying the weather and reporting it in that was started by Thomas Jefferson is still there today, and it's run out of the Smithsonian museums. And they're still a part of submitting temperature data. They now have weather stations that cost $100 and sit on a fence post. But that network is still there, and it's what allows us to have the weather predictions that we have. And today, recognizing we don't know what we don't know, we're trying to make all of the data available. There are places like Skyview Virtual Observatory that you can go to, and you can download data from the majority of the big public observatories around the world. And I bring this one up because down here where it says Digital Sky Survey, that data includes data from the Schmidt telescope up on this mountain. So you can go and download the old glass plates, now digitized, and look at what the sky looked like a long time ago when they still used glass plates. But side by side with it, you can get satellite data. You can get data in all different colors of the sky. We also make all of the planetary data available. And what's kind of amazing, and I just had the horrible realization, I don't know if this video will work. And we're going to find out. Yes, it's going to work. How exciting. This was made by someone who's a medical scientist in his spare time. He works on X-rays by day, or at least he used to, trying to diagnose illnesses. But at the end of the day, he wanted to do something a lot more beautiful than working on tumors. And so he downloaded data taken by various NASA spacecraft of Mars and put together a video that just died brutally. Let me see if I can get it going. Nope. Technology. Okay, well, we'll look at the beginning part again. So he spent his spare time putting together from real data flyovers so he could pretend to be gliding over the surface of Mars. He could pretend to be racing through the canyon lands of Mars, zooming in on the volcanoes. You can access all of this data through the NASA Planetary Data System. And if you do, you can make a video that will actually work on your own computer. And what's amazing is what we can do with modern technology. On the right is an image of Mercury that many of you may remember from your school books when you were a kid. And it was kind of ugly. And it's like, Mercury's the planet we don't have a good picture of. Well, a philosophy professor by the name of Ted Strike, he went in and downloaded all of those original Mercury images, put them back together using modern software, and got this amazing image on the right from the exact same data. But what we can do today with just Photoshop is so much better than what NASA could do with the best computers in the world when we first got the data back. And so Ted, who's a philosophy professor, now regularly gets hired by NASA to do image processing for them, to help them figure out what are the really interesting things they need to go look at with their spacecraft. And if you want to take your own images, you can use the telescopes right here on the mountain. Not all of them. You can't use the one in this building. But there's an amazing shed a little ways down the hill that says iTelescope on it. And you can use it to say, I want to image this asteroid that I heard about on the news. I want to image this comet that we're about to land the Philae lander on. I want to learn more about what I saw on the news by doing the science for myself and getting involved and helping the professionals who may not have the time to do everything on their own. And what we're working toward is a future where we can take all of the data coming down from all of these giant telescopes, run it through computers, figure out what we can, and there's going to be things that computers can't do. And so we take those things that computers can't do, and we ask the public to help. And where we have cool mysteries, we follow up with the best telescopes on the planet and around the planet. And this is all kind of daunting and scary, and it's like, how do I figure out what I want to do? It's hard. And so what we've done is my team at Southern Illinois, working with NASA, has built a website that's actually a lot more than just a URL. It's actually a community of people working to discover our solar system together. It's cosmoquest.org, and we have taken images from a number of different NASA satellites, from Lunar Reconnaissance Orbiter going around the moon, from the Messenger mission going around Mercury, from the Dawn mission from when it was at Vesta. And we post all the images online because we have scientists who need help mapping out these worlds. We're getting ready to start landing rovers on the moon again, and we don't know where all the craters are that are the size of this room. And we can see the craters that are the size of this room. And in fact, we can see the tallest people in this room if they were on the moon in these images. So we're asking for you to help us be the cartographers of a new age of lunar exploration. And what we're finding is if you get a group of people together and you ask them to all map together, they get results that all kind of line up, and that looks kind of messy. But we also ask a group of professionals to do this. So the top image is the markings of 8 different professionals. The bottom image we actually cut up into a whole bunch of pieces and gave each piece to 15 different volunteers. And when we compared the results, what we found was the average marking made by the professionals and the average made by the volunteers was the same. There was a 1 to 1.01 correlation, which is more accurate than when you compare 2 professionals, which means that we can get more accurate science by asking all of you to help us map the moon than we can get by paying 1 professional to map the moon on his own. And we sure don't have the funding to ask more than 1 professional to map the moon. So we now ask you, because you will do a better job. More numbers and stats, skipping over that. It's not just the moon. We've also worked with Vesta, which is really the world Dr. Seuss created. This is an asteroid that had a really bad moment a few billion years ago where it got smacked in the bum by another asteroid, kind of squished it in and created wrinkles around its waistline. And it has these amazing deformed craters all over its surface. And it's all kind of daunting, and you're like, I don't know anything about all of this. At least that's how my students feel, and I'm assuming you guys are probably smarter than most of my students because you're older and wiser and have seen more. Well, to help people learn, we've created a game that you can get for any of your phones. If you have an Android or an iPhone in your pocket, you can pull it out and go and download this game called Earth or Not Earth. And you can look at these stunning images and guess, is this Earth or not Earth? And it seems straightforward sometimes. But this, raise your hand if you think this is Earth. Raise your hands if you have no clue. Yeah, this is actually Mars. And what I love about this game is we made all the pictures black and white, so you can't cheat by saying, oh, I see trees. And I don't know anyone who's gone more than 15 images and gotten them all right. And this includes going up to the people who run the spacecraft. And so this is a chance to, on your phone, explore the solar system. And I'd ask that all of you at some point do remember to go out and look up. This is Comet McNaught that was discovered here by Robert McNaught. And you have some of the most amazing skies down here. Enjoy them, celebrate them. But then, please, go online and help us discover our universe. Thank you.